Many times, we need to access external databases from our Genexus applications. For example, we may need to load data from an external database to tables of our database associated with the knowledge base to make an initial load. After that, we may no longer need to stay connected to that external database. Or, we may also need to connect and stay always connected to a certain table or tables of one or more external databases, and not just to read them, but also to enter and change the data in them. Let's see how all of this can be done in Genexus. In our travel agency knowledge base, let's see in the menu, Tools, and choose the Database Reverse Engineering option. Selecting this option opens a wizard that allows us to apply reverse engineering to external databases. This means that for an existing database that contains tables, relationships, indexes, and so on, all the objects and configurations required for easy access will be created in Genexus. In this first page of the wizard, we need to enter the connection data to the database we want to access. Because the database we want to access is precisely SQL Server, in the DBMS option, we leave SQL Server. The connection type option also remains as is, and then we indicate the name of the server and the name of the database to which we want to connect. We click on the Next button and move on to the second page of the wizard. The tables of the database to which we're connected are displayed here. We must make sure to leave in the right window only those tables to which we want to apply reverse engineering in order to access them from our knowledge base. We need to access the customer and continent tables, so they must be in the window on the right. Before clicking Next, let's take a look at these other buttons. The Add Related button allows us to automatically add all the tables that have an n-to-1 relationship with the tables we selected. In addition, the Save Selection button allows us to save the table selection we made, so that when running it again later on, we can quickly load the same selection by clicking on the Load Selection button. We click on Next. The reverse engineering process begins in this moment. That is to say, the composition and everything related to the tables selected will be evaluated, and the Genexus objects required will be created. The wizard has three tabs: Report, Settings, Rules. Let's begin by the main tab, Report. The report that we're viewing informs us about the objects created during the reverse engineering process. Note that below the Objects folder, there's a Data Views folder and a Transaction folder. Below each one of them, there's an object called Continent and another one called Customer2. The first question that comes to mind is why the name Continent was kept exactly the same as the name of the external table, and why, for Customer, the name of the external table, the KB objects were named Customer2. The reason is that our knowledge base already had a transaction called Customer, and the corresponding table with the same name. So it wasn't possible to create another transaction called Customer, and that's why it was named Customer2, just like the other objects created to access the Customer external table. And what is a data view object? We haven't seen that so far. A data view object allows defining and configuring information from an external table. In other words, For each external table that we need to access, there must be a data view defined in the knowledge base. Since we're in the middle of the reverse engineering process, so as not to cancel it, we'll look at this image and comment how the customer2 data view will be defined. The first thing we see below composition is a list of attribute names. Note that for each attribute, there is an external name, the name of the physical field in the external table, and an internal name, the name given at the knowledge base level. That is to say, the internal name is the name of the attribute included in the transaction automatically created to access the external table in an interactive manner. And it's the name that will be included in all the GeneXus objects, such as grids, events, and so on. Below composition is the mapping of names of the table's external fields and their corresponding internal attribute names using GeneXus naming convention. In our knowledge base, we'll always make reference to internal names. And when generating the code in the corresponding language, GeneXus will make reference to the physical field names, taking into account the name correspondence defined in the data view. So, where is the external table name for GeneXus to make reference to the table when generating the code? Here we see that the external platform is SQL Server, and looking at its related properties, we see the name property that has the name of the external table. And where is the information of the external database in which this table is located? If we look again at the properties of the main node of the data view, we can see the data store property, which points to data store 1, which was automatically created in the reverse engineering process. Even though at the end of this video, we'll see where the data stores are defined in a knowledge base, for now, the concepts that we have to learn are as follows. Each data view has the information of an external table, and each data store has the access information to a database. Next, for each data view, we need to make reference to the data store it belongs to. So now, we'll take a look at the data view property called Associated Table. Its value is the name of the transaction associated with the data view. That is to say, the transaction that was also automatically created with the same name as the data view, so as to allow making additions, changes, and deletions in the external table in an interactive manner. Transactions associated with data views don't cause the creation of tables or reorganizations. They're not different from the other transactions, but when they're referenced in data views as associated tables, GeneXus understands that it'll only have to generate the form and its programming. The purpose is to allow interaction with the external table whose information is stored in the data view in question. It should be pointed out that transactions associated with data views can have, at most, the same number of attributes as the external table. They can have fewer attributes if some fields are not to be accessed, or at most, the same number as the external table. But they can't have more because GeneXus doesn't reorganize external tables. Note that if any errors had occurred during this reverse engineering process, they would have been notified. Okay, now let's continue with the other tabs offered in this page of the wizard. The Settings tab, as its name suggests, allows making certain configurations. For example, generate transactions, which is set to true by default. And, as described here, allows us to indicate that transactions are created to handle data from external tables interactively. If we change the value to false, only data views are created, not transactions. The option Identify Multi-Level Transactions, also as its name suggests, allows us to set whether to identify subordination relationships and to create transactions with more than one level as long as patterns that make it possible are identified. Its default value is false. As a result, every table to be imported defines a single transaction with a single level and the related data view. The option Generate Schema is set to true by default, and this means that the table schema data is stored in the schema property of the corresponding data view. We're not going to continue looking at each of the possible configurations, since by clicking on them, the necessary help is provided. So let's continue with the Rules tab. Since objects and attributes are automatically generated from an external database, some name conflicts may occur. For this reason, the Rules tab makes it possible to define name mapping rules to solve these ambiguities. Therefore, this tab allows us to state rules to rename attributes, objects, and so on, as well as change data types and make any necessary adjustments before generating the objects. In our example, we don't need to state rules of this type, but it's very intuitive to use, as in general all editors are. This is the last step of the wizard. We click on Finish. And now let's see what it generated. The data view continent and the data view customer 2, as well as the corresponding continent and customer 2 transactions. Okay, we press F5. In the Impact Analysis report, we can verify that the tables associated with the data views will not be reorganized. Let's continue. Now we'll open the Customer 2 transaction. Remember that through the Customer 2 transaction, we access the customer table of the external database. We can see the records that have already been entered. For example, we enter a new customer and we can see that the record was entered successfully. We can also modify the status of another customer and we can even delete the customer that we've just entered. We see then that we're actually working directly on the customer table through the Customer 2 transaction created by the reverse engineering process. Lastly, let's talk about data stores. In the Preferences view, below the .NET environment node, which is our execution environment, we can see the data stores below the backend node. What do default data store and data store 1 correspond to? As we've said before, a data store contains the information to connect to a database. When we press F5 for the first time in a knowledge base and prototype locally, the information related to the database is requested, and a default data store is created with this information. If we look at its properties, we can see that it connects to the database created at the time. It corresponds to the database related to our knowledge base, and within it, the tables that Genexus determines are created, analyzing our defined transactions. Which database will data store 1 connect to? With the external e-commerce database to which we've connected. Okay, finally, if we look at the properties of the data views continent and customer 2, we can see that they point to the data store 1 created automatically by Genexus in this reverse engineering process. To finish, and to see one more example running, we've created a very simple list with a list of continents. Note in the source of this procedure that we're making reference to the continent-based transaction and sorting by the continent name attribute. To run it, we right-click and select Run.